Okay, so for 9-3, proving triangles similar, there are 3 ways to prove triangles similar, and this is different than proving triangles congruent. So if you remember in chapter 4, or topic 4, we learned about 5 different ways to prove triangles congruent, and I have a poster about that on the posters page. But now there are 3 ways to prove triangles similar. And some of these are very similar to proving triangles congruent. And one we couldn't use to prove triangles congruent because it only proves them similar. So remember, before this moment, in order to say that 2 shapes were similar, we needed all the sides proportional and all the angles congruent. Now with triangles, we're going to have some shortcuts. The first one being angle-angle similarity. This is the reason why angle-angle did not work on proving triangles congruent. Because just the angles are congruent, it only shows similarity. 2 angles of one triangle are congruent to 2 angles of another, then the triangles are similar. Now you may be wondering, why is it not angle-angle-angle similarity? Everything else has 3 letters. Why doesn't this one? Well, we know if 2 angles of one triangle are congruent to 2 angles of the other triangle, and we know triangles equal 180, then the third angles must also be congruent. So really, we only need 2 angles to know that the third one is congruent. So it's really angle-angle-angle. We only need 2 to prove it. Now, for side-angle-side similarity, this is important because it's not that the sides are congruent. We're proving similarity. Remember, there's 2 key things about similar figures. All the angles are congruent and the sides are proportional, okay? So if 2 sides of 2 triangles are proportional and the included angle, that means the angle formed by those 2 sides, are congruent, then the triangles are similar. So let's look at what I mean by this. If AB is to QR as AC is to QS, and these 2 angles that are formed by those sides are congruent, then these triangles are similar, not congruent. Remember, squiggle for similar. They are similar by side-angle-side similarity. Okay? Now let's look at side-side-side similarity. Same idea. Remember, we need all the angles in 2 similar figures. All the angles are congruent and all the sides are proportional. So this is the only one that mixes them. This one shows the angles congruent. This one shows the sides proportional. So if the corresponding sides of 2 triangles are proportional, then the triangles are similar. That means if GH is to XY, as GI is to XZ, and HI is to YZ, we would need all 3, similar to all 3, all of these to equal the same scale factor, equal the same thing after we reduce them, then the triangles are similar, okay? Don't forget basic things like vertical angles are congruent, alternate interior angles are congruent, triangles equal 180, part plus part equals whole. These things that we learned first semester geometry, they still are at play here, okay? Along with 3 new ones about similarity. So let's look at some example problems in the textbook. So right here on example problem 1, using angle-angle similarity, right here it only gives us 1 angle. But if we think about it, these are vertical angles, and we know vertical angles are congruent. So then that's 2 congruent angles, which is enough to say that these 2 triangles are similar. Are they congruent? Probably not. Are they similar? For sure. Now let's look at this one. This says that 70, 70, 85, and 30. Well, that's not the same angle. Let's see if those add up. We know triangles equal 180, so I can do 70 plus 30 equals 100. 180 minus 100 equals 80. 80 doesn't equal 85. These are not similar triangles, okay? Now let's check using other similarity options. Let's check side-side-side similarity. For these, all 3 of these would need to be the same. I like how they do this. They do the shortest sides, so that way you don't have to figure out what matches up with what. If you're not sure how to turn it, we do the shortest side is 6, with the shortest side here is 9. Longest side, 10, with longest side, 15. That's also 2/3. And then the last side, just the middle side, 8 is to 12. Well, that's also 2/3. So because all 3 sides are proportional, The triangles are similar. This is our similarity statement. Triangles are similar by the side similarity theorem. If you just write SSS and don't include the little squiggle, your answer is entirely wrong. Notice all of these, it's not just SSS, because SSS proves triangle congruent. SSS similarity is entirely different. You have to include the little squiggle or your answers are not correct. Let's look at another one. We can do the same idea right here. Remember, part plus part equals whole. This part 12 is only to this. This part 3 is only to this. So this whole side, we're not comparing 12 to 3 and 8 to 2. This isn't a triangle. Right there, that's not a triangle. Notice how they separated it. 8 and 12 are, so 8 is to 10 as 12 is to 15. Those do equal 4/5. It's very important to understand, okay? Separate the two triangles. Treat it like a triangle, not like a triangle and a trapezoid, okay? Last one, right here, we have two isosceles triangles. Well, if one angle is congruent, the other angle is congruent. We have two angles congruent, which means we have angle-angle similarity. So that is what 9-3, proving triangle similar, is all about.